My name is David Bayer. I work in the Esri JavaScript API team.
And my name is Lloyd Heberlie. I'm a product engineer on the JavaScript API team.
Okay. The talk we're doing today is building offline apps using a hybrid approach with the ArcGIS API for JavaScript and the ArcGIS Runtime. That is a really long title, and the first thing that springs to mind is, why do I want to create an hybrid offline app between the two? So I thought we'd sort of roll back a bit and sort of start about why you might want to be doing this. Now, I think application development has got really hard in the last few years, really hard. And it's not because of the languages. The languages have got easier, faster, nicer commands. You've got words like async appearing in the languages. It's not because of those. It's because of all of the choices that we now have with application development. So when you look at application development, a few years back you were just writing them from computers. It was nice and easy. It was just a PC and the application would run. But now we have phones, tablets, watches. We'll soon have washing machines. The apps are being developed for every type of system. And with that, each of these devices has a platform or an operating system. So you have iOS, OS X, Android, Windows. So say you have to choose a target platform, and that kind of decides what language you're going to write in. Are you going to write in C#, Objective-C, Swift, Java? And based on that choice, you're suddenly into some different development tooling. You've got Xcode, and Android Studio, Visual Studio, Xamarin Studio. And with all of these, there's actually variations of all of these. There's other development studios that, I could have listed lots. And then when you're actually coming to write your application, there's all sorts of choices about what form factors you're targeting. And so it's all more and more choices. And it gets slightly worse because these choices are not mutually exclusive. You can't just say, I'm going to develop for Windows desktop. Because nowadays we're being asked to write for applications for multiple operating systems at once. You want to write for a Windows tablet, an Android tablet, an iOS phone. So we're having to develop our application several times, each time for these different operating systems. And that's a very common requirement. And that challenge of having to write for all of these different environments also introduces sort of an in-house skills challenge. Organizations typically have web developers, or a lot of web developers. Probably a lot of the people in this room are web developers. And that's because deploying business apps is really quick and easy on the web. You write your business app and everybody in your organization can use it. Also, we're writing apps for members of the public to get information about our organization. So organizations typically have good web developers. What they have difficulty having is a good web developer, Android developer, iOS developer, and Windows developer all at once. And so suddenly deploying these apps or creating these apps becomes a very expensive proposition. Now, Esri has the same challenges. We're developing apps for all of these different platforms. Also, we want our technology to be used by yourselves to build fantastic apps. So we've sort of recognized that there's development communities. There's an Android community, there's an iOS community, a Java community, and we've targeted runtime SDKs. And we've put great effort and focus into building rich SDKs with lots of documentation. And we're now maintaining that, and we're finding ways of both increasing the documentation, increasing the example apps, and also just building a community around each of those development communities. Also within those, we do have some cross-platform applications. So in .NET, we've got Xamarin, which allows you to write in your C# skills and target all of those different devices. And same with Qt. But what we find is that organizations still have a lot of web developers, and so who have great HTML5, CSS skills, and can make great mobile-friendly applications. But it's how those can be used. Another reason why application development is getting harder rather than easier is because the expectations are changing. Now everything needs to have a good UI or a good user experience. It must be responsive and easy to use. It must have really good visual aesthetics. It must have simplicity. It must be really simple to use. Simplicity doesn't mean simple to create and simple to make. It's really challenging to make an application that is easy to use. It's got to be touch. It's got to support offline and online. When you go into the field, suddenly you lose signal, your applications have still got to work. Increasingly this year, we're seeing voice come into things. And also there's trends coming in of the future of your app being predictive and more artificial intelligence in apps, so they actually work out what you want to do, so you have to do less in them. So it's not surprising that when somebody comes to you and says, build me an application, it's a bit of a headache. It gets an even worse headache when they say it must work on Android and iOS. There must be a browser version because I don't want to lose those people. It must work when I have no connectivity, and it must look amazing. Now, that is a bit of a headache, and it's a headache because of all the choices you're immediately faced with. Where do you start? It can be worse than that. It can be what happened to me a few months ago, which was I got asked to take an app that had taken a year and a half to write, and then the requirement came for it to work offline and on mobile devices. And that's a bit what led to some of the research project that we're going to show you a bit at the end of this project. But these are the challenges. Now, when you get challenges like these, it's very important to manage expectations. So a research company has gone and asked 100 app developers how long it takes to build a mobile app. And they've come up with this magic number of about 18 weeks. Now that's not saying a cross-platform app, it might be 18 weeks and then another 8 weeks for an iOS app. But they've also kindly put these nice other annotations on it saying that you could go to the moon and back 40 times in the same amount of time. So it's about managing expectation that mobile development is harder, and there are a lot of challenges associated with it. Of course, web development isn't easy today. Web development seems to have followed the same lines of getting much, much more complicated with a lot more choices. There are now so many frameworks and so many versions of the JavaScript standard that have been introduced over the years that even choosing where you begin with a JavaScript app or a web app is a challenge. And so what there is, though, within sort of application development using your web development skills is there is a framework called Cordova. And Cordova allows you to use your web development skills to write a native app. Now I'm going to pass over to Lloyd, who's going to run you through a bit more detail about Cordova.
Thanks, Dave. So, show of hands, how many of you have already used Cordova? Okay, it's quite a few. I think we'll get feedback if you leave your mic on.
Oh, sorry.
So we can't see the screen. You all can see my screen, right? The Apache Cordova. Okay. So the Apache Cordova is an open source project, and it has quite a vibrant community around it. There's also, we're not going to talk about it much, but people also talk about PhoneGap. And PhoneGap is Adobe's branding around Apache Cordova. So you can get support from them. They offer an online hosted build platform, kind of like we do with App Studio, where you can upload your code and it'll build the app for you, and you can take a picture of the QR code and download it to your device. But today we are going to focus on Cordova. In the guide, we do have an article that talks about using PhoneGap, and it just kind of covers, what it is, maybe if you haven't heard about it, why you would use it. I mean, most of all this you're learning today in here if you didn't know that already. but it just talks about some of the different tooling and some of the considerations and gotchas that you can run into. One of the bigger things is the content security policy, or CSP, and that can really kind of cause a headache whenever you deploy the app onto the phone. And then it's basically, as things get more secure, they get more locked down, and whenever you open your app up and assets don't load, then you have to figure out how to open that up with that security policy. And so there's information in here about that as well. They can't see it? All right, thank you. Okay, so let me back up, not repeat the whole thing, but basically this is the guide topic in the API reference, and the big thing in here is the privacy, security, and whitelists. You can read through all the other stuff. I'm actually going to walk you through a demo of building this, but this is the part where you will lose your mind and lose a lot of time whenever things don't load on the device in the app because it's being blocked by the content security policy. And if you don't know how to debug the app, you won't see that either. Whatever it is you're looking at won't load. You won't know why. And when you actually debug it, it'll actually show in the content or in the console that it's been blocked by these content security policies. So there's a lot of resources in this article that point you to setting up the system that you'll have to get going in order to use this tooling and some different frameworks and stuff that we're going to talk about. So that's some reading for you. Another colleague of ours, Andy Gupp, you've probably maybe attended some of his sessions here at the conference. He has a repo on the Esri GitHub organization that's called Quick Start Map PhoneGap that works with PhoneGap and Cordova and just covers some basic content of apps that you would work with. There's also some more resources under my personal repo. There's another session that we've done in Dev Summits and user conferences past where we talk about jQuery and PhoneGap, and so there's some resources in here that could be helpful for you. And there's a lot of resources out on the web as well. Do you see the Cordova architecture slide? Okay. So what we're dealing with here is that, as David mentioned, you get to leverage your web skills. HTML, JavaScript, CSS, those are things that you as a web developer are familiar with. The Cordova architecture provides plugins that have native code basically that hook into the device-specific functionality, whether you're on iOS or Android or Windows Phone. Those plugins are things that you will likely search for and install in your project if, say, you need to hook into the Touch ID device on an iOS device. Going farther up the stack, you have the Cordova container framework that actually has the web view. Basically, it's the headless part of the browser, missing the Chrome and the windowing that you would normally get on a desktop. It's the browser for that given device. And then from there, you have your application code that's your web code that you're familiar with. And then if you're using any plugins, there's going to be code in JavaScript that will hook into those plugins to get to that native device functionality. And then at the end of compilation, you actually get this native app. So as I mentioned, these plugins provide a hook or an interop so that you can make JavaScript calls that call the plugin that then hook into the native device functionality, like the compass or the calendar, so you can add events or things like that, or even the geolocation. And in the Cordova repo, they actually have a link at the top that will take you to like the plugins page. And let's see that if we just search for that touch ID. So this fingerprint ID that works with the touch ID sensor. Some of the stuff out there is free, some of it might be paid for. You'll just need to check on the licensing. But this is a great place to start if you're thinking about, hey, we have a business requirement for our application to do this certain feature. Potentially there's already a plugin out there. And Dave is going to talk more about when we get into later in the session with some of the plugin stuff, and he can probably give you more info on that. So with using things like, with the PhoneGap build, there are options where you can upload code and it'll just compile it for you and give you the app. But there's other times where you're going to be doing more specific things, writing your own custom plugins, or maybe you're downloading the source code from a plugin from the plugins repo or repository and you need to tweak it and stuff. And so you're going to need to be able to build, test, and compile these things in your own dev environment and put them on the devices and make sure that that all works before you're deploying this to the stores. So there's installation prerequisites. Dave talked about the platform setup. If you're using the Android Studio or Xcode, if you're going to target iOS or Visual Studio, needing a Mac, needing a PC, needing the devices, needing the tablet. I mean, if you're a gadget geek, it's kind of a cool, fun thing. You're like, yay, I get to go on a shopping spree. But at the same time, that is, there's only you, and you're spreading your resources over this hardware as well as your time working on and testing on these devices. So there's pros and cons to the whole thing. And then you have to learn how to debug and, get the devices attached and enable the USB communication. It's not rocket science, but it does require patience and learning. And if you don't do it on a daily basis, you forget how to do it as well. So I always recommend that whenever you're doing development, if it's not specific to some native functionality, test that code in the web browser first always. You need to kind of become a detective and learn to test, does this work in the JavaScript API in just a browser? If it does work, then move on to the device, because whenever you have problems, you need to decouple the complexity of the issue, and a lot of that can be easier if you just remember the simplicity of test it in little pieces across the platform and across the different devices before you just run into an issue and you just throw your hands up in the air and you're like, oh, it's something wrong with such and such and I can't go any farther. You're going to have to learn how to debug this stuff. But first things first, you'll need a web server. If you're doing web development, you should know that. You'll be managing your source code. You'll be getting these IDEs installed. You'll need to set up Node because Cordova runs on top of Node. You'll need to get the Android tooling installed. You'll need to get Visual Studio installed if you're going to target Windows Phone. And you'll need to join the Apple Developer Program if you're going to deploy the app to a physical device. Without paying, you can deploy to the emulator, but that doesn't really do you anything other than just kind of show you a pretty picture of it, because the emulator uses the hardware that's on your Mac, not the hardware that's on the device. So you won't get a realistic approach.
It's worth saying in all of this, everything we're saying at the moment is true of any mobile development. So even if you're using Xamarin or you're just writing it again, one for one device and one for another device, it is just a big step that's worth getting really right from the beginning, because it will save you hours of trying to work out why your environment isn't set up correctly in the first place. And then once you've got that tooling in place, then you can really begin to storm in your development.
Right. And you really won't go through the headache again until you have to get a new machine and reset up your whole dev environment. So it's really important to take good notes when you're doing this so that you can go back and look at those and remember what you had to do in order to get things to work. With the devices, you need to enable the remote debugging. And with Android, there's dev tools where you enable the USB debugging and trust the device. And so let's dig into a demo here where I'll show you creating and compiling this. So, once you've got Cordova installed, you can just quickly check out to see what version you have installed. And also, if you forget any of the commands, you can always just say Cordova-H and it will give you those. But in order to save grace here, I'm just going to copy and paste these. So you'll see there's my Hello Cordova app. And then there's the files in there. And so we'll add the Android platform. And then we'll just run this real quick for Android. So if you have your device plugged in,
I was worth saying that's quite incredible that in 3 command lines you've gone from not having an app to having an Android app and having it running, and it's built all of the kind of components and elements that you need for your app to run.
So it is actually deploying it on my phone. I have a recording of this that you'll be able to see, but just so you sort of trust me, we'll cover this in the debugging as well. If you go down here and you say remote devices, it says that my Google Nexus 5 is connected, and if I hit inspect, you'll see there's the code that's actually here listening and running on my device. So let's run the, see how long this takes. We may or may not watch this. Okay, that was lovely. So let's open this in Finder. And then under Platforms, you'll see iOS, and then there's my Xcode project. So one of the things I want to point out to you here, there's a lot of stuff that's going on beforehand here with joining the Apple Developer Program and then signing up for these identities and getting your provisioning profile. All that stuff has to happen. The doc on the Apple Developer Program is really good about walking you through how to create a certificate signing request and upload that and get all those things set up. But the important thing here where this will not build is that if you don't have that set up and you need to set the team, which allows you to sign that, this doesn't work. You get a bunch of errors that says, oh, you need to have a team in order for this to compile, because basically it's signing the app, compiling it, and then deploying it to the phone.
You can use the emulators without the signing, so you can still run it on the emulator on your Mac, but it's so important to run these applications on the devices to get a real feel for how they're behaving and what glitches that might occur. Right.
So here we're just inspecting the local resources here. You can't see a preview of it with the Safari remote inspection, but you can actually see the various files that are on the device. And I have a video here that we can watch that shows what this actually really looks like whenever you're remotely debugging this and the app runs, and you can set a breakpoint in the app that's on the device and then inspect it through the remote inspection. So just as before, we're looking at the inspection of that app. We've got a breakpoint set here, and then whenever I refresh the app, it will then pause the application that's actually physically running on the device, and then you can go into the console and type commands for wherever you're currently in the breakpoint and see that information. This is what you'll be doing whenever you're debugging the code that's running on the device. And it's the same thing, seeing it running on the iOS device, and you'll see that the breakpoint stops, and you can inspect the code the same thing. So whenever you're sitting in front of your desk with your devices, set up, and you're doing this development, you're seeing it right in front of you. But these demos never work with screencasting the device, so you guys can actually see it. So that's why I recorded these videos. But that's just a basic boilerplate Cordova Hello World application where it puts all the files and the stuff in place for the different platforms. So when you do the platform add, it adds in the Xcode project, or it adds in the Android project or the Windows project, so you can then compile these applications and run either through the command line, or in the case of signing, with iOS.
I mean, it's worth saying in all of this that most of the time you're just going to be writing in HTML5 and CSS and JavaScript, but when you're coming to deploy it, that's where you encounter the sort of the platform and the deployment and the sort of actually experiencing your app on the device as a native app.
Right. So using Cordova and the JavaScript API, you'll be including the JavaScript API, you'll be including your normal source code that you're writing. As I mentioned, the CSP, the content security policy, the whitelist, the things that are saying, here we're allowing this to access certain resources. And I think Dave's going to talk a little bit about more, but with the JavaScript API, there's a bunch of files that are included in that Dojo library. And when you include all those files in your app, all those files have to be transferred over USB to the device. And that will cripple your development time, because you'll build and sync and deploy, build, sync and deploy, build, sync and deploy to the device. So it is actually okay to use the CDN for development whenever you're just trying to get your app done and working. And then when you get farther along in the development process, you can investigate using a custom build of the JavaScript API and just deploying those minimal files on the device, so in case you do need to do an offline scenario. So just a little bit about the application lifecycle, very similar to what we have before with the Cordova architecture, except now we're adding more into that. So you have the phone operating system loads up, you have the native application that loads, you have your application code that loads, plus any third-party libraries that you're using, like the Esri JavaScript API or some other JavaScript library. And then you have the map load, and then once the map loads, then the layer loads. And so there's all these different points in the life cycle of your application where something could potentially go wrong, and you'll need to know how to debug and understand that. One of the important parts, or where I set the breakpoint, was this device ready event. And that's basically something that Cordova fires whenever it's ready. And so after that is whenever you can start doing your application loading, or device APIs, or loading plugins, things like that. So here's just an example in the device, on device ready, we're loading a map. There's also pause and resume. So like if you minimize the app or bring it back to life, those are events that you can listen to as well, that you may want to shut down things that you're doing so that you don't drain the end user's battery. And so some of the deployment considerations are, dealing with the stores that and the guidelines that they have for submitting applications, optimizing the API like we talked about, and just dealing with the signing and submission. So we're going to talk a little bit about Ionic. Dave's actually used that in his project. And basically this is a framework that helps make apps look more native for the device. They have CSS per the given platform that makes it look like it belongs. It's built with Angular 2 and TypeScript, and it uses Webpack. And so this is kind of what we were talking about earlier, where there's all these technologies in here. This is a great tool that works for you, but if something doesn't work, you need to understand what the different pieces are and how it actually really works. Anything you want to?
Yeah, no, sorry. Yeah, Ionic is absolutely great. It's built on top of Cordova, but it gives you a lot of HTML components that are really optimized. When you use mobile devices and you're sort of going up and down lists, on a native device, in a native application, that's really smooth. I'm echoing. It's really smooth. And what Ionic have provided you HTML components where they've spent days and months optimizing every single HTML element so that it's not overusing the DOM, so that it's not thrashing the DOM and these kind of things. So it's loading images optimally. And what those components give you is as close as, well, to be honest, you can't tell that they are not just native lists and native controls. So, and also, what's nice about Ionic is it takes choices away from you. They've said, Cordova says, write your app in HTML and JavaScript, and your app will work. Well, if you've not written any bugs, but your app will work. Ionic have said, no, your app will be Angular 2, it will use Webpack, it will be written in TypeScript, and by saying that that's how your app will be, it's taken away choices and you work within those frameworks. And so that's quite nice. And they have put a great amount of engineering into their CSS and into their components. So it really is a quick route. I mean, I think, are you going to be giving a demo? Mm-hmm. So we're going to give you a demo of just how quick it is to get to a mobile app that looks really, really good.
So Ionic's already installed. And it's, if you're familiar with Node, you can just say npm install Ionic. And I went ahead and ran the other command while we were waiting just to save some time. So this Ionic start, hello Ionic, and then tabs. Tabs is actually a template. And we'll look at that here in a minute. And then there's another neat thing that Dave taught me before, as in preparation for this. You can say, you got to be in the directory first. It has a labs function that will actually show you what that app looks like on the various platforms that you've chosen. And you can actually, click on those different things. And you see how on the iOS one, the bar's at the bottom here. On the Android one, the bar's at the top. So it's a quick way for you to visualize what that's actually going to look like on the app, in case maybe if you don't have your devices yet, or you want to do this because it's quicker than doing it the other way. And the other one that I was going to show you was, I have a map demo. And essentially what we did here was we took the tabs template and put the map into the home tab. And so this uses some additional technology that exists in some other projects, but this is just sort of the step where you go from the hello world to your first Esri integration, baby steps, get this stuff going, and then keep doing your building as you go forward. So there's a Tom Wason, who's an Esri employee. He's done some presentations here at the Dev Summit this week. He has a Angular 2 Esri loader project that was used in that sample. There's also an Angular 2 Esri example. He has a blog where he talks about using the ArcGIS API for JavaScript and applications with Webpack. So that could also be some helpful reading for you. And then there's the Ionic tutorials where it talks about how to install Ionic, and then also how to use the labs. So using Ionic and the JavaScript API together, it's the same as for Cordova. There's a little more challenges. You got to figure out how the load the JavaScript API using Dojo inside of Angular's framework, and that's kind of where those projects with that Angular loader comes into play with the projects from Tom Wason. And then dealing with and understanding how the Webpack runs and bundles up the app before it gets deployed, and then reading and understanding TypeScript, which is a sort of a superset of JavaScript. And so hopefully with these projects, and I plan to put, actually there's another sample out there I'll look for whenever Dave's talking, that is actually, Andy Gupp has an Ionic map sample that's out on the Esri GitHub repo, and I'll show that to you. But we need to keep going, and I'm going to turn it back over to Dave, and he's going to take us through the really interesting research that he's done.
So going back, we started this talk, well, the name of this talk is Hybrid Offline, no, I can't remember the name of the talk, but it's got Runtime SDK and sort of hybrid apps. And really, when you start looking at one of the problems with app development, it's when you're offline. A Cordova app will work offline absolutely fine. It's just HTML and CSS. But how do you start working with maps and the Esri JavaScript API, and what happens when you go offline? Now, before we sort of go into this, the research kind of side of things, it's worth saying we have solutions to this problem. We've got the runtime SDKs. There's the Qt SDK. There's the Xamarin SDK. All of our runtimes support taking apps offline. So we already have very good ways of working and writing mobile apps that work offline. What I'm going to talk about now is if you're wanting to write a hybrid app with Cordova or Ionic and still using the JavaScript API. And why might you want to do that? It's because you might want one single code base, one code for the web, and the same code running on your apps. I have no idea why there's a picture of a rabbit on this slide. So if we do a storyboard of what this app might look like, I would imagine that the app will have a splash screen that will appear. I get that straight away with Cordova. I would imagine it's going to have a login button that's going to take me through some sort of OAuth login to log into your portal. I then want it to show me a list of maps. I then might launch one of those maps and see some details about it. I then might want to open one of those maps online, so I'm just using it online so I can view it. But I might want to click download. and take it offline. And then I might have a different view of that app when it's offline. I might want to synchronize it. I might want to delete it. And I might want to view the offline instance. So, I mean, this research project came about because of that project I told you about 4 months ago, where I was told to take a 2-year set of development into an offline application. So I didn't want to rewrite the whole application in Xamarin. It would have been a good route to go down, but I couldn't face writing the application again. So we sort of looked at what the stack was in the application. So the application ran in a web browser. It was a nice HTML5 CSS app. It used the Esri JavaScript API. And when you looked at what it did, it went down and it called services. So, you know, if you think of it, an HTML app, it just makes web requests, HTTP requests to a service. So if you now look at a Cordova app, you've got an HTML5 app, you've got a JavaScript API in there. But instead of talking to services, what if you could talk to the Runtime SDK? So that when you're offline, instead of talking straight to the services, you talk to the runtime. And that was the kind of idea behind a mechanism of still keeping all of the investment that had been done in the web app and keeping all of that investment, but using the runtime for what it is good at, which has got geodatabase, synchronization, being able to query data, and query the tile caches. So when you start looking at this, what you can do is look at how the request pipeline happens in the JavaScript API. And the request pipeline, nearly every single request from the Esri JavaScript API goes through Esri request. An Esri request is built up on top of Dojo XHR. And Dojo XHR is built on top of the browser's probably XHTTP request. And then it eventually hits ArcGIS server. So the kind of slightly underhand mechanism of achieving an offline app using the Runtime SDK is to hijack the requests, is to intercept them at the lowest point and handle them yourself. And what that generally means, I originally tried to do it at the Esri request, but that's very well written and there's no way of actually breaking into it. But at the Dojo XHR, you can override that and then you can spot the HTTP requests going through and decide what you want to do with them. So once you've got that piece, the next piece is how you use the runtimes. And that's where Cordova and Ionic have their plugin mechanism. So you can use the plugin mechanism that's provided by provided by Cordova and write your own plugin that uses the runtime SDKs. So I'm going to show you the app, or attempt to show you the app. Then I'm going to show you bits of the code, but I'm not going to go into too much detail of it. But it's just to show you the philosophy of kind of how you could go about this. As I say, this is very experimental, but it might be a way that if you have a very large app or a similar sort of situation, that you could go about it. So what I'm going to do, can you switch me to 4? Actually, yes, if you switch me to 4, but I might ask you to switch me back out while I enter my password. So you should see on the screen, this is the simulator, and it's simulating an iPhone 6. So when I click login, if you switch me out, the number of people who've lost their passwords by typing it in. Oh, I'm on the wrong. Sorry, I'm. Okay, if you sign me back. So I don't know what, you didn't see me log in, but it took me through an OAuth process. And that OAuth process, it's worth saying that's not the standard Esri JavaScript API OAuth process. Because I want a mobile app login, I've had to code a mobile, I have to do a slightly different request to get a slightly different token, and it's a token that will last for a long time and that I can refresh whenever I want. So because I want this app, if I shut it down and when I next start it up again, I don't want to have to log in again. I might be out in the field offline. and I don't want to be blocked from doing my work because I need to log in again. So that's going to be stored somewhere on the device, and that token I can use when I'm next online and reactivate it. So here it's gone off and got the list of web maps. If I choose this one and open it, that's just opening it up. And so that's all absolutely standard JavaScript API and so forth. But if I click to take offline, first of all, I'm going to change. Whenever you do a mobile app that takes data offline, you don't need to bring down all the data. So this is saying I don't need tile caches from the really detailed level. I only need it at a certain level. And it's always worth looking at what amount of data you need to take offline. I'm now going to draw a region and click export. So that's going to take a bit of time. So I'm going to potentially switch to this. 3, yep. Okay, can you see my phone? Okay, so now that app is offline and I can click open. And what you're seeing is that same data. Now here, I'm now effectively offline. As I'm panning, what's actually happening is the HTTP requests are being sent, but I'm intercepting them and instead handling them in my plugin. And then I'm just returning the HTML as before. So through that approach, I've been able to take a map offline and use it in a Cordova runtime app. And for all intents and purposes, that's a standard phone app. So I'm going to switch back. Okay. So just to give you an idea of what that application looks like, so first of all, it's a standard Cordova app. So a Cordova app, you have a source folder where you put your Angular 2 components and your HTML. And I've created a map component to wrap all the logic of my map. So I have an HTML element there, and I have my TypeScript code behind it. And what's potentially interesting is that I detect, am I offline? If it is offline, then get the offline metadata that I've saved somewhere and use an offline utility to create the map. If I'm online, make sure I'm signed into the portal and just create the map using the standard Esri JavaScript API. And what there is that uses a plugin. And the way you write a Cordova plugin is you have a source folder, a www source folder, where you write, if you like, the JavaScript interface to your component. So I have an interface of get credentials, obtain license, create geodatabase from feature layer, and possibly most importantly, query and get tile. So those are the two things that are really called the most when I'm panning and zooming around, getting the tiles and getting the query. Then what you do with a Cordova plugin is you provide the implementation for each platform. And we have the runtime SDKs, so I can go in and I can look at the iOS Swift code. Now, I only learned Swift a few months ago, and my Swift is terrible. So if you're a Swift developer, I apologize for the number of question marks and exclamations I've put everywhere. I just put them in until it told me I didn't need them. So if I go down, so here I've got my create geodatabase from feature layer, and really all I'm doing is writing using the samples from the runtime SDK. There's a task object called, and you set the default geodatabase parameters, and then I generate a job to go and then I start the job, and all of that's doing in iOS. That's the code you need to go off and get a feature layer and create a replica and put that as a geodatabase on your machine. And I've got a similar function for getting a tile cache, and I've got a similar function for doing a query. And again, there's an implementation for Windows and for Android, one in Java and one in C#. And the way you bring it all together is you put in a plugin XML that just says how the plugin should work or what files it should get. The plugin can do things like get pods if you're so you can get the runtime for iOS delivered as Cocoa pods. For Java, for Android, it uses a Maven package, I think, and for C# it uses a NuGet package. So it can drag down the runtimes from their respective package managers. So I'm not going to go into much more detail about that because there's a lot of code there, but it's just showing you that as a pattern. If I go back to the slide deck, just to recap the challenges. So in true object-oriented style, you have to inherit all of the challenges from writing a Cordova app, an Ionic app, a runtime app. And you've got some additional workflows that you need to think about how you would do. You need to think about the OAuth process because you want a different sort of OAuth. You need to think about how to take a tile package offline, how you need to take a geodatabase offline, and this request hijacking. And the downside is you have to write the Cordova plugin 3 times, once for each environment. It's worth also saying this is a route that you can use to get to building a desktop app. So not a web app, but a desktop app that runs as a true desktop app. And there's a technology called Electron, which is which runs, if you like, the Chrome engine. And there's a whole other set of technologies there that's also an interesting route to getting cross-platform apps. And we've been talking about Cordova for this talk, but there's a number of emerging technologies that are also worth having a look at. We've got things like React Native and NativeScript. React Native allows you to write an app using JavaScript that runs as a native app, but it uses native controls. So it means it's not quite as portable. You don't write it quite once for the web and once for the phone, so the kind of markup is not quite as portable, but it reuses massive amounts of your code. NativeScript is also emerging. And that NativeScript, again, has the same kind of philosophy. They let you write your app using Angular 2, and they boil it down, but they allow you to use CSS, but their markup is not HTML. But they've got a common markup that then goes down into native controls. And so again, these aren't quite hybrid because they actually ultimately end up as absolute runtime apps. And both of these technologies have the ability to write plugins. So again, similar sorts of patterns or even other ways could be considered. So I think I've given you more choices. So I don't think I've actually helped you in this talk. But what I've tried to show you is that with Esri, we've got runtime SDKs for all the different platforms. But the key is to understand your requirements and only do the work, only target the environments you need to, because there's a lot of work in developing for each platform. And also, what Lloyd was showing there is the development community with Esri. There is lots of material and lots of examples for writing Cordova apps, for writing Ionic apps, for writing Angular 2 apps. And if you do any work in creating plugins, please do share it with the community because it allows us to very quickly get more capability and develop things in different ways. So I think that's we're probably at the end of the session. So please do give us feedback, and if you have any questions, have we got time for questions, or do we need? Oh, okay.
Did you show some of the code for the interceptor? I think
Okay. I'll show you the interceptor. My only caveat is it might not be very nice code, which is why I didn't show it. So I've created a utility class. So I'm looking for my hijack method. So remove offline intercepts in it. So basically, there's 3 lines of code. Dojo.xhr, I keep the old one, because you should never throw things away. And then I replace the Dojo.xhr with my own function. And in there, I spot what kind of query. I basically analyze what the request is. And then I've looked at the Dojo implementation of how the rest of that function is implemented, and have pretty much copied how it's implemented, but have just worked out how to do it. So the Dojo code is all under GitHub, so you can see how they've actually implemented that function. But that's how I've gone about that. Okay, it's not quite as bad a code as I thought.
So when you take the app offline, at that point you're using the runtime offline capabilities. And is that using mobile map packages, or is that using something before?
No, currently I have to go through the web map and work out which layers and call create feature layer for each, create feature database for the ones that are all from the same server. But saying that, I do know that the runtimes are looking into how to make it easier to take web maps offline. So it might be worth talking to the runtime teams to find out what they're doing in that space to make it easy to take a web map offline. It's a very good question. The reason we haven't put it up onto GitHub so far is because literally the ink is only just dry on it, and it's in a really shocking state. So I need to go through, tidy it up, and then potentially we might put it online, but I can't guarantee it yet until it's stabilized a bit. Basically, it's a research project, so it was trying to see whether this would be a suitable route to take the app offline.
So in follow-up to that question, if you are pursuing this type of an application deployment, we would love to have your feedback from the team perspective. So I can get your business card, and someone from product management, probably Julie Powell, would be contacting you, and to try and figure out if this is a viable thing for the future that would make sense to take away resources from something else and build and develop into something that's real and not just a research project. So I'll be at the island after this, or you can just come up here as well.
Okay. Yeah.
I think you kind of answered my question, but I'm curious what is happening to make this more of a built-in available feature in an SDK from Esri. Is this going to keep going, or is this mostly research?
Sure. So the question was, where did this come from, and is it something that we're pursuing going forward? Does that kind of wrap up what?
Yeah, well, I mean, earlier in the conference, talking to the runtime SDK team and asking them where they were going with offline JavaScript, they said that there may be some efforts to look at offline JavaScript as, a feature or an available flavor of an SDK.
Right. So I think you were saying that you had talked to some of the folks from the runtime team, and they were mentioning that there may be in the future an avenue for using JavaScript to take the runtime SDK offline.
I think, it's whether there's a community that this would be valuable to. So if you look at our runtime SDKs, what we're trying to do is address a community of developers where there is demand or a need to be able to use our technology, because we've got some, we haven't even got into geocoding and routing and all the sorts of things you can do with our platform. but we want to give the best SDKs and the best tooling to you as developers. Whether this gets taken forward is whether there's a need amongst the community for it. So that's why we're very interested in getting your business cards and talking to see whether it's something that would solve problems for you or make things worse by giving you another choice that at the end of the day makes development harder. So it's a real sort of double-edged sword.
So in all seriousness, I mean, today, right now, 5 minutes from now, whatever, you could go to the ArcGIS Ideas site and somebody could create something based upon from the title of this session, I want this. And if all the 100-some people of whatever that was in here say, I want this, and then other people get a load of it, I mean, I'll tweet the link out, and customers talking is what gets things rolling, and so.
But also negative feedback is just as valuable. I don't want this. It's just as useful for us to know. So.
Okay. Thanks for attending the session.